Hi students, now we are going to explain the variation of acceleration due to gravity with altitude or height. Now what is meant by acceleration due to gravity first of all? When we drop any object, it will fall towards the center of the earth. So some force is acting on the object that is called the gravitational force. And because of the gravitational force, a body which is freely falling from rest continuously accelerates. And this is due to the gravity of the earth. Therefore, it is called acceleration due to gravity. At any point on the surface of the earth or slightly at a very less height above the surface of the earth, the average value of acceleration due to gravity G is 9.8 meters per second square. That is for numerical calculations we have assumed. Is it not? But if the object is going to greater heights above the surface of the earth, by inverse square law, the gravitational force acting on the object will be reduced. So there will be small change taking place in the acceleration due to gravity at some heights. So that we are going to derive an expression for that. Now look at this diagram. This is the earth whose radius is RE and mass of the earth is taken as ME, capital ME. First I will keep an object of mass small m at a point A on the surface of the earth. So where is the point A located? On the surface of the earth. Now, on the surface of the earth, the acceleration due to gravity, we will get an expression first. So, at point A, on the surface, okay, this is on the surface. The acceleration due to gravity is given by small g equal to capital G into mass of earth divided by the distance square. So the distance between this object of mass m and the earth of mass me, center to center distance is almost equal to Re itself. So this is distance square and this is our equation 1. Next I will assume another point which is at a height h above the surface of the earth. So next I will write acceleration due to gravity at point B. So where is B? B is at h above the surface of the earth. So here I will use the symbol GH. G subscript H. So this is equal to capital G into mass of the earth divided by the distance square. So what is the distance of this object of mass m from the center of the earth? We have to substitute. So it is Re plus h the whole square. So this is Re plus h the whole square and this is what equation number 2. Now we have to get an expression for this g at a height h in terms of g on the surface. Okay. So for that let us divide equation 2 by equation 1 on both sides. So left hand side, so I will write dividing equation 1 or equation 2 by equation 1 also we can divide. Okay, we must get an expression for GH. So I will divide this GH by G. So left hand side is GH by G. So right hand side I will divide G ME divided by Re plus H the whole square. Instead of dividing by G, I can multiply by the reciprocal of G. So this is Re square in the numerator. Re square divided by capital G ME. So I can cancel this G and ME on both sides. So now I get GH by G is equal to Re square divided by Re plus h the whole square. Okay. Now this I will simplify like this: re square divided by, in this denominator re plus h term I will modify by taking re as the common factor, so that the first term will be 1 and the second term will be what? H by re, is it not? So re plus h can be written like this. Then there is a whole square. So square bracket I will use now. It is a whole square. So that if you open this bracket, means first term is re into 1 is re, plus h into re by re get cancelled, you will get h. So I have modified this for simplification. Okay. So that this is now equal to re square divided by, so this is a into b whole square, is it not? So a square into b square. So the first term will become what? Re square into second term will be what? 1 plus h by re the whole square. Have you understood up to this? First of all, mathematical steps you have to practice by writing. So this re square and re square can be cancelled. So left hand side is gh by g and right hand side is what? 1 by 1 plus h by re the whole square. So I will write here. Therefore gh divided by g is equal to 1 divided by re plus h. So I will write as it is 1 plus h by re the whole square. Okay. Now if I will shift this 1 plus h by re the whole square to the numerator, the power 2 will become minus 2. In that form I am going to write. So this can also be written as equal to 1 plus h by re the whole power minus 2. So this is our equation 3. Now this equation 3, I am going to apply binomial theorem, which is a mathematical tool. Now you see h is the height above the surface of the earth. Initially I will assume that the height above the surface is less than the radius of the earth. So by applying binomial theorem, when can this binomial theorem can be applied? If h is very much less comparing to the radius of the earth. So radius of the earth is 6,400 kilometer and above the surface the height can be a few hundred kilometers only. So under such a situation I can apply binomial theorem. Okay. From the binomial theorem, 1 plus x whole power n is equal to 1 plus n into x power 1 divided by 1 factorial plus n into n minus 1 into x square divided by 2 factorial plus next term will be what? X square, then x cube, x power 4 by 4 factorial, like that it will go on. But what we have assumed is h is less than re, is it not? So h square by r square, then h cube by r cube. If you take the denominator is very large than the numerator h terms. So the value will be diminishing. Only the first two terms will be meaningful. All other terms will be negligibly small. So we can retain only the first two terms, and hence I can write that this is also equal to what? 1 plus nx, 1 plus nx. Okay, so 1 plus nx. Now in this 1 plus x whole power n format, n is equal to minus 2 and x is equal to what? H by re, is it not? So what is 1 plus nx? Let us see now. Therefore gh divided by g is equal to 1 plus n is equal to minus 2 into x is equal to what? H by re, h by re. So this is equal to 1 minus 2h divided by re. Okay. So after applying binomial theorem, now we have got gh by g is equal to 1 minus 2h by re. Therefore, what is gh is equal to g into 1 minus 2h divided by re. This is the required final equation number 4. Okay. So GH is equal to G into 1 is G. Minus of something means it must be definitely less than the value of G. So we find that GH is less than G. Understand? Hence, G decreases, the value of G decreases with increase in height. Or altitude. Now, my dear students, here when you solve the IIT and NEET problems on this variation of G, you have to be very careful. This equation must be applied only when the value of h is very much less comparing to the radius of the earth. Suppose you take height h in this problem, height h is equal to the radius of the earth. What will happen? Then 2 into h divided by Re. So that Re and Re get cancelled. 1 minus 2 will become minus 1. So G dash is equal to minus G will come. Is it not? Is it possible? It is not possible. Then how to do such problems? Whenever the height is either equal to the radius of the earth or twice or thrice and multiples of the radius of the earth means we cannot use this approximation because this is based on binomial approximation. Is it not? When under the condition when h is very much less comparing to the radius of the earth. So in solving such problems where the height is multiples or comparison with the radius of the earth means then you will have to divide the second equation by the first equation directly. The answer will come immediately. Understand? So when the height is very much less comparing to the radius of the earth means this equation number 4 we can handle. Otherwise, we have to divide the second equation by the first equation. The constants will get cancelled and h can be applied and answer can be got. Okay. Okay, my dear students, this is the variation of G with respect to the height. Now, in this case, when you stand on the surface of the earth or above the surface of the earth, the entire weight of the earth is going to pull you. But it is not in the case when you go below the surface of the earth. That we will see in the next video. I hope you must have understood well. Fine.